Okay, so what I want to do first is there's just an interesting problem from the book, and I actually had it in your old notes, but I just had a blank for it. I didn't actually write the problem, so I don't want to take the time for you to dig up your books and all that, so I'm just going to tell you what the problem is. Chapter 1, or section 1, 1.1, is about mathematical modeling. And that sounds complicated, but what it really is just taking a real world situation and trying to use math to figure it out. Okay? So here's the problem. A bakery sells a 9 by 13 cake, so 9 inches by 13 inches. So you know what that is? That's just a regular, oblong pan. I'm sure your mom, like you bake brownies and stuff in. I'm sure your mom has them, so maybe you do too. And they sell that cake the same price as an 8-inch diameter round cake. Okay? These two are the same. Go into the bakery, you can buy just a rectangular cake, you can buy this round cake. Now the difference is the round cake is a layer cake. So it's 2 times the height of it's like 2 layers, and this is just 1 layer. Got it? They sell for the same price. So your question is, which should you buy if you want to get the most cake for your money? In other words, if you want the best deal, which one should you buy? They're the same price. We got this regular single layer, we got the round double layer. Okay, what are your thoughts on that? How do you think we can figure that out? Who signed this, Sean?
Lady that does lanyards.
Oh, okay, so you were down there getting a lanyard? Okay, got it. Okay, any thoughts on that, anybody? Come on, wake up. No one has any idea? Okay, so if I want the most cake for my money, shouldn't I kind of look at the volumes, do you think? The volume of the cake, that's how much cake you have. So this is a rectangular cake. How do you find the volume of a rectangle? Oh my gosh. Times height. Length times width times height. That's how you find the volume of a box, right? So the volume of this cake would be length times width. Now they didn't tell me what the height was. All they told me was this one is 2 times as tall as this one. So I'm gonna make up a height. I'm just gonna say it's only 1 inch tall. Now I'm allowed to do that because I am comparing these 2 quantities, and I know this height is twice this one. So if I make this 1, I'm gonna make this 2. If I make this 2, I'm gonna make this 4. I'm allowed to do whatever I want because I'm comparing. I don't know exactly how big this cake is. The question is, which one is the best deal, okay? So I'm just comparing the 2. All right, so 9 times 13 is 117, cubic inches. So I'm gonna get 117 cubic inches of cake for whatever the price is. All right, now what about this guy? He's a round layer cake. How do I find the volume of that? What shape is that? That isn't a box. That's not a rectangular solid. What's that? What shape do we call that? Well, it's certainly its base is circular, but I've lifted it up. I made it like a tall circle. What do we call that? Not a sphere. A sphere is a ball. A cylinder. This is a cylinder. So your layer cake, you may not have thought about that before, but it's a cylinder. Okay? Now, how do we find, anybody happen to know this? The volume of a cylinder? Oh, did you people take geometry? Come on. Pi r squared h, pi r squared h. What does r stand for? Radius. H stands for height. Now, be careful, the problem said that the diameter of the cake was 8 inches, which means its radius is 4. So this is gonna be 4 squared. And then the height, remember we said the height is double this one? And since I made that one 1, this one's gonna be 2. So I'm gonna type that in on my calculator, using my pi button, times 16 times 2. That is 100.53 cubic inches. So if you buy this cake, you get 117 cubic inches. If you buy this one, you get 100 cubic inches. So which is the best deal? The top one. Now, in the real world of business and economics and running a company and selling cakes, do you think anybody would ever buy this one? Would there ever be a reason somebody would want to buy that one? It looks better. I mean, when you think of a nice cake, don't you think of like a layer cake, all nicely iced and everything? So less cake for your money, but a more pleasing appearance. Absolutely. Okay, so there's a little bit of exposure to mathematical modeling, using math in the real world. Now what we're gonna do is do some math not from the real world. So get your notes out. Where did I put my notes? And let's look at solving some equations. Now this is kind of review. We did a lot of this already this year. I promise things are gonna heat up a little bit here, get a little bit more fun. But right now, we're just kind of solving some more equations, getting some more practice. What do you think of when you look at this equation? You think possibly we could do this? Now, I probably wouldn't because I'm not too sure about that guy right there. But with this kind of a problem, is this an option? Now, it doesn't always work, but it's an option. Okay, who else has a thought? What?
Quadratic formula.
Quadratic formula. Could I use the quadratic formula on this? Yeah? You know what? There are people in this room that still don't know the quadratic formula. Not excusable. No excuse. Learn it. If you don't know it yet, you need to get it learned. It's never going away. So, learn it. Okay, so Wyatt?
Can we do the parentheses and multiply everything by 30 or the third?
Okay, now, let's get rid of this, because I don't think this is gonna work. It might, but I don't think so. But I love Wyatt's idea. I could do the quadratic formula using A is 1, B is -4, and C is -1/3. I could do that. But what if I multiplied everything by 3? Everything by 3, so 3 here, 3 here, 3 here, 3 here. Can I still do the quadratic formula? Yes, but now I don't have to mess with fractions. If you don't mind the fractions, then go ahead and do it, but I think this is gonna be easier for me. So here we go, x equals -b plus or minus the square root of b squared, which is going to be 144. I noticed on your papers, guys, some of you you're writing b squared, so you're writing it like this, and then you're typing it in your calculator, and it's coming out negative. Is b squared ever going to be negative? Never. B squared is going to be positive. So my suggestion is just go ahead and write that down. Just do 12 squared. Write down 12 squared here. But if you're going to write this down, you've got to have that in parentheses, or your calculator will give you the wrong answer. This is never going to be negative. this guy right here, that number is never going to be negative. Minus 4 times A times C all over 2A. And there are still people only putting the radical over the 6. Nuh-uh, the whole shebang is over the 6. Make sure you're getting the whole thing over there. Okay, what do we got under here? I see a minus, so that's gonna be 144 plus 12. So that's 12 plus or minus the square root of those two things added together, which is 156. Now, I don't think 156 is a perfect square, but you can check it. It's a big number. You can check it on your calculator. I don't think it is. So what do I have to do? Since 156 isn't a perfect square, I'm going to have to break it down. So here we go, 156. I always do 2's, you don't have to, but that's my particular style. So it's 2 times 78, and 78 is 2 times 39, and 39 is 3 times 13. I think I'm done. So how does that simplify? 12 plus or minus. You guys are making it rough on me this morning. What comes out? 2. What stays in? 39. That's multiply, remember. Does that reduce? Yes, because you can take a 2 out of all 3 spots. This triangle here, anytime you can take the same number out of all of those, you need to do that. So we're going to take a 2 out of everything, so it's going to leave us with 6 plus or minus square root of 39. You can put a 1 there if you want. And that's over 3. And there are the answers to the question. Okay, nothing new there, right? That's review. Okay. Anybody have a thought about the next one? Take a look at the next one. It's a big equation. Any ideas on how to solve that?
Can we start off by exploring the x plus 1?
I think that's a great idea, Kate. Let's get those parentheses taken care of. So we've got this. And now I'm gonna FOIL this next part. So I'm gonna take first times first, outsides, insides, and last. And then don't forget there's that plus 5x on the end after you get it foiled out. Makes sense to everybody to start that way? So just FOIL, you can do that, easy enough. All right, now what?
Move everything to one side.
So we got a bunch of collecting like terms to do. So Wyatt wants to get everything over and equal to 0, and I agree with that, totally. And the steps you go through are up to you, whatever works for you. For me personally, before I start moving, and Wyatt, you can move right now. You can, right at this moment, you can start moving. But before I do, I'd like to clean this up a little bit. That would help me get organized. So I've got an x squared. And how many x's do I have? I have a -2, a 1, and a 5. So what does that make? -2, 1, and 5. 4 x's. And now I'll move. So I'll move my x squared, my 4x, and my 2. So x squared minus 4x plus 2. So there's the 0 that Wyatt wanted, which is awesome. We want that, definitely. So we have 2x squared minus 8x plus 4. Now what?
Now
What?
now do we FOIL or factor?
We can try to factor, absolutely. Now, Tilly, anytime you have an x squared, you can try that. Now, it's not always going to work. We saw that in our last problem. What I would suggest that you do, and again, this is just like a Lisa Ford thing, I would want to divide everything by 2, just to make my numbers smaller, make it easier to work with. That is perfectly legitimate. You are absolutely allowed to do that. You don't have to do that. It just makes your problem a little smaller. Now, Tilly, I'm looking at this. I don't think this is going to work, is it?
No, we switched to the quadratic.
So we'll have to use our quadratic formula again. Does everybody see how this isn't going to factor? So my quadratic formula, x equals negative b plus or minus the square root of b squared, which is 16, positive, 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 minus 4 times a times c, all over 2a. Now, this one is actually going to be a subtraction, isn't it? 16 minus 8, so that's just going to be 8. Now, do you remember how I canceled in the last problem? Okay, you can't do it yet in this problem because I know 2 goes into 4. But you don't have a number here. You have to be able to cancel in all the spots. Do not try to cancel the 8 because the 8 is underneath a radical and he's not cancelable. You can't like reach up in there and cancel him out. So right now there's nothing to cancel. But what is there to do? The 8, no, these don't cancel. You can't cancel this, boys and girls. Stop. You can't. If you're going to cancel those 2, you have to have a number here to also cancel. It's the only way it works. You gotta have all 3 spots. You don't, so don't. But what about 8? It breaks down. So what can come out of the 8? And what's left over? Now, guys, can I cancel? Yes. Yes. So what am I going to end up with? 2 goes into 4. 2 goes into 2. So 2 goes into 4 twice, once, and once. You do not need to include those ones, but you can if you want to. That exact thing, or not exactly, but close to that, happened on your test. Some of the tests had a problem that came out like this, I think. Now, how would that cancel? See this right here? Everything's gonna cancel, so that would become a 1 plus I, and then over 1 if you want. But you don't have to put it over 1. Okay? Some of you took that thing and you canceled those 2. Can't do that. Gotta cancel all 3 places. Okay? All right, next, C. What about this guy? Would distribute. I definitely would distribute. So I have x squared minus 4x equal to 5. Then what? I would move the 5 over and get it equal to 0. Guys, it's a quadratic. We like to have our quadratics equal to 0. So just like you did in this last problem that I just erased, move everything to one side. Now, all morning we've been talking about this. I think this one actually you can do that with. Could you also use the quadratic formula on it? Yeah. But I think, how does this one factor? I think it does factor x equals, or x, excuse me, x
And negative 1.
minus 1 plus 5. Double check that. Don't I need a negative 4? So don't I need this one to be negative and that one to be positive? Negative 5 and positive 1. Lucy, how you doing this morning?
I'm fine.
Okay, good. All right, now what? You're not done. Factoring isn't the answer. X equals what? Negative 1 or x equals positive 5. Guys, when you pull a number out of a parentheses, you change the sign. Right? You change the sign. You're setting it equal to 0. Would I have gotten the same answers if I did the quadratic formula? Yeah. Would have been a little more work, but I would have gotten exactly the same answers. Okie dokie, Smokies, here we go. Last one on this page. What are you gonna do with this guy?
Move everything to one side.
Move everything to one side, so maybe add the 3x squared. And subtract 10. So 4x squared minus 15 equals 0. Is that okay with everybody?
Add in a 0x as a placeholder.
So Wyatt says, you don't have to do this, but you should realize it's in there, right? There's no x, the x is missing. So if you plan to use the quadratic formula, your b will be 0. Now, can I use the quadratic formula? Absolutely. So here we go, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So some of you may be thinking about doing this problem a little differently, and that's okay, but this is fine. This is fine, it's quadratic. This is going to be a plus underneath there. What is that, 240? Will somebody do that for me? Is that right? So I have 0 plus or minus the square, by the way, you don't need the 0 there, but it's okay to have it. Plus or minus the square root of 240 over 8. Now what? That looks a little different. What now? Yeah, we're gonna break it down. So 240, and you'll break it down however works for you. I'm gonna do 2 and 120, and 2 and 60, and 2 and 30, and 2 and 15, oh my gosh, and 3 and 5. pair of 2's here, and a pair of 2's here. So I'm bringing 2 out twice, which is like bringing out a 4. And all I have left is my 3 and my 5, which is just 15. What do you think about that? Can I cancel my 4 and my 8?
Well, yeah.
Actually, you can, because there's no other number over here. So here are your 2 answers. 4 root 15 over 8 and negative 4 root 15 over 8. Those are the 2 answers. Can't you cancel 4 and 8? Yeah. So we get root 15 over 2 and negative root 15 over 2. Now, I wouldn't be able to do that if I had like a 3 out here. I wouldn't be able to do that, but there's nothing out there. So it's just like having 4 over 8. So here are the 2 answers to the problem. Did anybody have a different idea? Well, I'm going to show you something. When that B term, you recognize right off the bat, my B term is 0. When your B term is 0, I think we talked about this before, you are allowed to move the C term, the constant, over, get x squared by itself, and then square root. What happens when we square root 15? We just get the square root of 15. But what happens when we square root 4? Look at the 2 answers we got. Aren't those exactly the same as we got with the formula? Right? TV, you doing okay? All right, let's sit up. Act like this is the most thrilling thing you have done in days. Okay, thank you. All right, guess what, kids? That's it for 1.1, so that homework is going to be due on Wednesday. All right, or no, today's Tuesday, so Thursday. That homework will be due on Thursday. 1.1 homework. And it should all be reviewed for you, pretty much reviewed, just extra practice. All right, so now we're moving on to 1.2. Here we go. Which of these are functions? C is a function. All right, I'll go with that. So C's a yes. What?
B.
B is a no.
Oh, D.
B is a no.
C. D.
We already said C. B's a no. C's a yes.
Is A.
A is a yes.
E.
E is a yes. It's kind of hard to tell on my picture, but this is the picture. This is the actual function. Just a T. Okay, that is a function. So A and C and E are functions. A, C, and E. Tell me why B and D and F are not.
Because of the line check.
They don't pass the vertical line test. Do you remember the vertical line test? Let's take a look at picture B. If I draw, either physically or in my mind, a vertical line down through that picture, see how it hits right here? And it hits right here? If a vertical line, any vertical line, hits your curve in more than one spot, you are not a function. Does that sound familiar? Now look at this guy, this TP. A vertical line. How many times does he hit? No matter how many vertical lines I draw down through there, purple hits blue only once. That means it's a function. If blue hits black more than once, it is not a function. Okay, that should sound familiar. You guys have done that. All right, number 2. This is huge. So we're going to write down 2 domain rules. So somewhere on there, I didn't leave you much space, but maybe over to the side or somewhere, you're gonna write down 2 domain rules. The denominator cannot equal 0. Ever, ever, ever. The denominator cannot equal 0. The number under the radical must be greater than or equal to 0. So if you have a radical in your problem, whatever is under it, and when I say under it, I mean inside it, right here, whatever's inside that radical has to be a positive quantity. If that's negative, then we end up being imaginary, right? The whole I thing, we do not want that. So these are the domain rules. All right, so let's look at problem number A, 2A. These are the 2 rules. Denominator, does this problem have a denominator? No. So you don't need to worry about rule number 1. There is nothing to worry about. There's no denominator. Does this number have a radical in it? No. So guess what? Your domain is negative infinity to infinity. In other words, all real numbers. What are you talking about? There are only 2 ways that you're going to screw up your domain. If you have a fraction and if you have a radical. If you don't have a fraction and you don't have a radical, then you don't have an issue and the domain is everything. Now look at B. What does B have? B has a radical. So what do I have to worry about whenever I have a radical? Whatever is under it, x plus 5, has to be bigger than or equal to 0. When you have a radical, whatever is under it has to be bigger than or equal to 0. Which means if I solve this, x has to be bigger than or equal to -5. Which means my domain is -5 to infinity. Your domain always starts out everything. If you put a fraction into it, that messes it up. If you put a radical into it, it messes it up. Okay? All right, let's look at C. What's happening in C? Do we have a radical? Good, we don't have to worry about that. Do we have a fraction? Yep. And what's the fraction rule say? The denominator cannot be 0, which means x cannot be -5. So x can be every number in the whole wide world except -5. And I'm good if you just write that down. You don't have to put that in an interval. I'll show you in an interval, this is what it would look like. But this is one of those cases where it's way more writing So it's okay if you just say x can be everything except negative 5. It can't be negative 5. All right, D. What do you think about D? I didn't mean to, but I just erased my rules. Okay, what are my 2 domain rules? Every time the question says something about domain, I have to think about 2 things. What do I think about? Denominator and radical. Okay, I don't have to think about that one here because I have no radical, but I do have a denominator. So what do I have to worry about with the denominator? The denominator cannot be 0. So I'm gonna solve that. And it looks like my domain is x cannot be 1/4. Which means that if you're picking x's for this problem, that's your domain, you're picking x's, you can pick any number you want except 1/4. Don't pick 1/4. Because 1/4 will make the denominator 0. Okay. Oh man. Let's skip E for a moment. It's kind of tricky. Let's go to F. We'll come back and get E, but let's do F. You guys are kind of drowsy anyway, so I don't want to overwhelm you. All right, let's take a look at this problem. Anybody have an idea what the domain is?
X can't be 0 because 3 is 0.
Yes. It has a denominator. Denominators cannot be 0. So when I solve that, it says x cannot be 0. Very good, Kate. That is exactly right. X cannot be 0. Because 3 times 0 is 0. Perfect. All right. Somebody else have an idea about this one? What's your domain for this one? Tell it.
Stretching, but I can try it. You just said everything that equals 0.
Well, your denominator can't be 0. That is absolutely true. The denominator can never be 0. Have you noticed anything about this?
Differences.
Difference of squares. Which means that factors into x minus 3, x plus 3. Which means that neither one of these can be 0. So you know how normally you set them equal to 0? Well, now we're setting them not equal to 0. So what does that tell me? X cannot be 3, and x cannot be negative 3. So you can pick whatever x you want for this problem, except 3 and negative 3. There's 2 things down there it can't be.
So when we're finding the answer, basically like the answer is what we can't do.
When you're doing a denominator, yeah. Yeah,
So we have to figure out what is what make it what is 0.
yes, exactly. Yeah. Okay. Hang in here, folks. Take a look at the next one. Letter H. Louis, what are my 2 domain rules?
That the denominator can't equal 0.
Okay, so let's stop right there. Does this have a denominator? Yep. So x minus 2 cannot be 0. Perfect. What's the other domain rule?
They can have a minus.
Whatever is under the radical has to be greater than or equal to 0. So whatever is under the radical has to be greater than or equal to 0. This domain is going to be in 2 parts because you have a radical and you have a denominator, and those are both domain rules. All right, so what does this mean? This means x cannot be 2. And this means that x is greater than or equal to -5. Now again, when I write that as an interval, it just complicates everything, so I'm gonna let you just leave it like this. If you want. Now, if you want to go ahead and write it as an interval, it would look like this. That would be your interval, but I'm okay with this. I'm okay with you just writing both parts of the domain issues there. Why is this a 2-part answer? Because it has a radical, rule number 1, and it has a denominator, rule number 2. So it has both. This problem over here only had one issue. It had a denominator. So I only had to deal with the cannot be's. Does not equal, is not equal to. But here I had both. All right, try I on your own. Can you figure out what the domain for I is? Look at it. Remember your rule. Anna, what's our rule for this problem? What have we got here? We've got a radical, and what does that rule say?
Is it, do we do 2 minus x is greater than or equal to 0?
That's exactly what it would be. It would be 2 minus x is greater than or equal to 0, because the rule says if you have a radical, whatever is under it is greater than or equal to 0. Real easy, that's the rule. Now I need to solve this. So I'm going to subtract the 2. And what am I going to have? Negative x greater than or equal to -2. And now I'm going to divide by -1, and what does that mean? The sign is going to switch, and x is less than or equal to 2. Now, just to keep things consistent, I'm going to let you write that too. That would be an easy interval, but I'm just going to let you leave it this way. So for all your domain problems, you can just leave your answer the way it comes out. Because I'm so nice, I want to make your life easy. All right, perfect. Nice work. Jack, were you going to ask a question about that?
I was gonna ask why we did it differently on B and made it a different, like, setting.
On B, no, on B, we said x plus 5 is greater than or equal to 0. That's what we said for problem B. Not sure what you wrote down, but that's what it always is. Whatever is under the radical, greater than or equal to 0, never changes. Always the same. So maybe you're thinking, I wrote my answer to that as an interval. I'm okay with you writing that. That would be the answer to B. All right, J and E we still have. So let's get J done. What do you think about J? Josh?
Would it be the same thing as the last one?
It would be. So what would you write?
3x plus 1 is less than or greater than or equal to 0.
Perfect. Anytime you have a radical, and the question says, what's the domain? You take whatever's under the radical, greater than or equal to 0, and then solve it. So here we're going to subtract -1 and divide So would you agree x is greater than or equal to negative 1/3? Okay, so it's super simple. Domain questions are super simple. Denominator cannot be 0. Whatever's under the radical greater than or equal to 0. All right, so what makes E complicated? Well, let's look at it. First of all, does E have a radical? So I don't need to worry about that rule. That rule's not part of the problem. Does it have a denominator? Yes. So what's my denominator rule? Whatever the denominator is, it cannot equal 0. Okay? Well, look what happens when you try to solve this. Moving the 1 over, dividing by 3, and then what would we do? Square root. And what's going to happen when I square root? Beep, 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 beep. We got a problem. What's the problem? What happens when you square root a negative? You get imaginary, right? Imaginary. We are talking about real graphable things here. I's aren't graphable on a regular Cartesian plane. So, believe it or not, the domain for this problem is everything, because there are no numbers that can make the denominator 0. Think about it. If you square, multiply by 3, and add 1, is that ever going to give you a 0? Think about it. Isn't this going to be positive? And what happens when you take a positive plus a positive? Do you get 0? Never. So even though that problem has a fraction, there are no domain issues because nothing will make the denominator 0, okay?
So when we're solving for the radical, you basically just solve normally and then whatever the answer is, just like the answer.
Yeah, I'm not sure. We solve everything normally. I'm not sure what your question is. Whatever is under the radical greater than or equal to 0. Period. Whatever is in the denominator cannot be 0. This one's a little strange because you get an imaginary root and that can't be part of your domain. So you throw it out and it's everything. There are no issues here. The denominator will never be 0 in that problem. Now, all the other ones we had that had denominators, we had things. X cannot be 2, X cannot be 3, whatever it worked out to be. But this one, even though it has a denominator, the domain is still all real numbers.
But for the radical, you always take it out like normal and just set it straight over.
Greater than or equal to 0. Yeah, those are the rules. Those are the 2 rules. Whatever's under the radical, greater than or equal to 0. Figure out what that is. And whatever's in the denominator cannot be 0. And figure out what that is if you can. If you can't figure it out, then your domain is everything.
And is that why we had negative
Because there's no denominator.
so
And there's no radical.
there was nothing, so we
There's
couldn't
nothing to worry about. Right?
Yeah.
Yeah. So only radicals and denominators pose problems for us. If you don't have a radical or a denominator, then you don't have any.
Or if it comes out like that does, that's what we have to do.
Okay, we're gonna do one more problem. And then we'll call it quits. Our objective, by the time we're done with all this, is to be able to graph what are called rational functions. So, problem 3A is an example of a rational function. It is a function with a fraction. They're called rational. And it says, find the vertical asymptotes. That's all. We're not graphing this whole thing. We're not ready to draw that whole picture yet. But the first step to drawing it is what we call the vertical asymptotes. Anybody know what vertical means? What does vertical mean? Show me. Vertical means like that, right? It's like this, up and down. Okay. Anybody know what an asymptote is? Well, they can be slant. An asymptote is, let's say, these would be slant ones, but these are asymptotes. These lines right here, they contain the figure. They kind of shape the figure. You think of it, you guys are too young to know what a girdle is, but back in the old days, women wore girdles to contain their, like, blubber. So here, these asymptotes contain that picture, kind of squeeze in on it. A vertical asymptote comes from the denominator. That's the note you need to take. Vertical asymptote, denominator cannot be 0. Oh my gosh, does that sound familiar? It's like domain. So in this problem, x minus 1 cannot be 0, which means x cannot be 1. So your vertical line, and we'll use a dashed line to show it, a dashed line, 1, there's 1, 2, 3. That line is your vertical asymptote. Whatever x can't be is going to be your vertical asymptote. All right, we'll do some more of that, and next time we'll add in horizontal asymptotes also. So that will be fun.